All right, so if I can weasel around here and get me the old trusty to open this up, we'll see what we've got. We got a bunch of pieces. What does that look like to you? That looks like a whole bunch of pieces of a drone. And wow, I don't even think it said it came with a remote. Radio Master TX12. Come on. So, I'll be. All right, well, cool. That's nice. It really is. So, hopefully, they didn't mess anything up pulling this thing apart. Because it's just been kind of goobered in here. That's very, very bad packaging for sure. So I'll check the box better later to make sure everything's there. But they did not include the screws. With the item. And I know all this stuff was screwed in the pictures. I could see the screws. So I'll have to look at that better, but irregardless. I know this was loose in it. This right here was all actually the way it was supposed to be. I don't know where the base mount, but this was mounted. So I don't know. I will have to. So you got upper and lower sensors here. There's that. Got to make sure all the wiring is up to kilter. There's some kind of a light, which is probably show. Okay, so that's a switch. I don't know exactly what that switch is supposed to do. Because, I mean, I'm still learning about drones. I don't really know what I'm talking about come to drones. But this has got a 4G card in it. So here's here's why this drone was built. Again, I didn't realize I had the controller, but this drone was built by whoever built it to be able to fly anywhere in the world where there is a cell phone signal from wherever you're at with an internet connection or with a cell phone signal or internet connection or any of that good stuff, because you connect through the internet with the cell phone setup, which I should be able to get that re-registered. That shouldn't be a problem. But we'll look at all that. So all this stuff, I'm probably going to just tear it completely down and start back up from building it up from scratch, because I need to see if I've got extra screws for these two pieces that they took out and didn't include the screw. Or hold on, wait. No, that's not it. Hold on. Okay, I'm talking crap. I apologize, because there's the screws. So we got the screws and a toolkit. So that's nice. I think this is a pretty honest seller. I mean, you don't get that a lot, and that's bad in eBay world anymore. But I'm really kind of looking forward to fiddling with this stuff. So these right here are probably Arduino components. I don't think they're just drone components, because I've got a bunch of these here myself. And what these are, they are, just consider them to be proximity radios. They'll let you know how close you're getting to something. In robotics, I've got a ton of robotic stuff, and these are used to let the robot know, hey, you're getting close to a wall, turn around. Or you can tell it, you may program it to where it'll do, cut a pie, a quarter, or maybe thirds, cutting a pie, or eighths or sixteenths, however you want to program it to do. And then when it sees a clear path or a low enough signal that it knows it's far enough away, it can advance to a certain extent, then it continues on. And so that's what these do. And you got another one in the back, which I can't imagine these being, so see there, we got that. See, they got, I don't know, I really wish they hadn't just jerked it all apart and thrown it in the box. I'm really concerned that some of this stuff may be destroyed. I don't know. You know, we got that. I don't know what that is. Maybe that's the radio control. That's some kind of antenna. So maybe it's a Bluetooth connection. So I've got to do a lot of research and checking and seeing what I can figure out on this particular drone. And that's why I got to just tear it down. I can't just leave this as is to try to sort through this whole mess. I'm going to have to, you know, take it down to figure it all out. This right here may have actually just like been installed in one of these slots. That might have been how it was installed. I'm not sure. But the GPS module is another reason why I was drawn to this controller, or to this offer, because it had the GPS on it. So let me see if I can. Yeah, so that's how it is. See, they got a hole drill right there. And so that's what they did. They mounted this straight into the deck, which is a pretty decent idea. I may do it on the other drone. I don't know. But these are designed, if this one is set up like that, to where you should be able to unscrew it, which it doesn't seem like this one is, but it should be. And then you can take and fold this down so you ain't got to rip it off. But I'll have to try to get this stuff loose. Looked like they glued it or something. They may have had problems with it staying connected. So let's get back to the cell phone part of this. So this is, of course, a Pickhawk 2.4.8, but it has a Arduino underneath this 4G telephone card. And the Arduino is an onboard assisted computer to this flight controller. And that's what can enable it with the GPS connection to go anywhere, literally anywhere in the world. I mean, if it had the battery capacity, I could have it take off here and send it across the country. And hopefully with these obstacle avoidance sensors, which is not really going to work that well, but you still have the potential for this to make it across the country without issue. That's no guarantee, but again, like I say, this drone has the potential to operate quite efficiently far outside the line of sight, which I understand is supposed to be illegal with a drone. You're only supposed to operate a drone within line of sight. So I'm going to get some pictures of this, see, because these connectors aren't connected and they're folded back like they're extra and are not needed. So that's part of telemetry, which is going into the Arduino. And so I'm not really sure what program the Arduino is running, who knows. So I'm just going to take a lot of pictures on how this is put together and what's connected to what and how and where, and kind of rebuild this back from the ground up to get it to a stable state and remount all of this conglomeration. I really don't like all of this just built up as high as it can be right here, and that's all it is. These are 3D printed parts, which I can reprint just fine. But this is the exact same flame wheel frame kit that's on the other, the one we just are still in the process of finishing. So get my words out there. I like the way they did the wires. That's a good idea. I really like some of the things they did with this drone, and I'm probably going to try to mimic them on the other drone. So I just wanted to get this open and looked at so I can confirm it. Today's my birthday, so they are, my wife and kids are taking me out for dinner. So there you have it. So anyway, probably I'll get some more pictures of this later on this evening, get it saved, get this torn down, or I may do a video on taking it down and bringing it back up into a finished state. But this is not the drone that I really want to concentrate on. I want to finish the other drone, get it in place how I want it, and then go from there. I may have some other stuff coming. So just be on the lookout for more drone stuff. I've always wanted to get into drones. I could never, it was too expensive, and all I could get was those little cheapy, $20, $30, $14, $15, $10 drones that really are useless and don't fly worth a flip, and they just kill your desire to deal with a drone. So I definitely recommend that you get at least a kit like this right here to build up on. And I'm hoping this series of videos will help to be able to do that, that you can get it built and functioning. These Pixhawk controllers are supposed to be pretty good. The other one's got a APM 2.8 controller, and I've got some other controllers and some other kits, not kits, but piles like this coming to work with. So this is just a little quick introductory, which is probably not quick, but we'll get this edited down a little shorter, and we'll get this posted out there to let you know some of the other stuff that's coming up that we're going to deal with. But this one's kind of cool because you technically you can put a camera on this, but you really don't need a camera on this because you got global positioning, not just the GPS is what I'm talking about, but you got global control. Because normally with any drone, you are limited to the range of the controller itself. So however far this right here will reach, that's how far you can operate that drone. And some of them will get out there far enough that you can't see the drone anymore. But that is kind of moot with this, because you can literally, as long as it's got a cell phone signal, this can go out as far as there's a cell phone signal. And you can control it through the computer from like a ground control setup, the way the military actually does drones. And so this drone right here is kind of an equivalent of that right there. If you heard, how was it? I think it was Ukraine. I think it was them attacked Russia, and hopefully I don't get in trouble for just saying those words, but I think it was them, one or the other attacked one, and I don't remember how, and they used drones, and they're all in a vehicle. And so it was all set up. They were all in little boxes, open top boxes. So the top opens up, and these right here, they are remotely through a cell phone signal, or satellite signal, or whatever, however they use, but the same style of technology. And they were activated, and they take off. And they were already programmed with coordinates as to where they needed to go, and they were packing explosives. So, and I don't know if it was this size of drone, but potentially, probably, because this drone is supposed to be able to pack a decent amount, and the explosive wouldn't have to be really heavy to do a lot of damage. And so take off, go where it's got to go, and do what it's got to do. And it's got the GPS coordinates as to where it's supposed to go to do that. And so this drone right here has that potential capability. And so I thought it was just cool to be able to try to develop that. So that's what this drone is. This is a potential remote operated drone. And I see some resistors in line here. Kind of conglomerated in, which I would do all that in heat shrink. So all that would probably get redone to some extent or another. So I got a lot of work to do with this, and I don't even know if this this Arduino works. I don't even know what brand it is, what grade it is, because I got tons of Arduinos. And so I'm going to check all of that out. So there's a lot to do to this drone. As a matter of fact, I may just take and get this back on there because it was in there already. so that I don't lose track. And I think I may have mentioned it in the initial or the current drone construction, that you have drones that operate clockwise and counterclockwise. And I really didn't explain that. And I still got some more filming to do on that series of videos, and maybe I'll remember to do that. But the reason that I can think of, now I could be wrong, I'm just using theory and what I know about things in the world. If this motor spins this way for lift, and this motor spins this way for lift, and this motor spins this way for lift, and this motor spins this way for lift, then the whole drone ends up spinning this way as it's lifting, because everything inertia is spinning like this, you know. And so worst case scenario, it may start doing a gyro like that. And so in the setup, which there's maybe other ways to configure them, but in the setup, say these two right here would be spinning this way for lift, and these two right here would be spinning this way for lift. And so this is going this way, this is going this way, and so the centrifugal force is canceling each other out. Okay? And so the same thing is happening over here. And because these are spinning this way, and this one's spinning this way, it's doing the same thing here. So all of the motors are cross-canceling one another in the centrifugal force. Now, right there, you can see there's a pretty decent distance in between there. So these could probably do with some larger propellers. Okay, so we're going to start documenting this teardown. First, what I'm going to do is try to take pictures of the top of the flight controller, and maybe we can keep track of where everything is plugged in, if we're lucky. So this right here, so obvious things, buzzer's plugged into buzzer. We have, let's see, I'm like this right here. I don't know what this switch is. I don't know if there's a start switch. I don't know what that is. So I'm just going to document that the start switch is plugged into switch. So I'm just taking pictures. And I've always done this to try to keep track of what all I got going on. And it's really worked well, but it helps you, or helps me anyway, to definitely put it back together. I didn't say put it back together right, but just put it back together. Pure and simple, to have pictures. So this, I think, is a Spectrum receiver, and I only say that because the remote, the Radio Master TX12, was set up for Spectrum, and I assume it went with this. So we're just gonna take a picture. Now I already know that the 4G antennas are hooked into the Arduino, and so these other four here, those four wires are the controllers for the they're the wiring for the motors. And I'm trying to think and do this. It's like me, you know, thinking and chewing bubble gum and walking. You know, once I get to the walking part, it's like, man, that's over with. Ain't happening. So the sensor array. So it looks like I'm going to call them proc sensors, proc switches, because that's what I'm used to from an industrial background, but these aren't. These are just, I think these are, I don't know. distance sensors. I don't know what you call them. I've used them, but apparently they don't. They're not impressive enough for me to remember exactly what they're called. So here's the GPS. I'm going to take a picture of the wiring on it, and obviously it goes in only one way. You got GPS, and then right here the other end is plugged into the I2C slot. So we're just going to leave that as it may. And so the GPS antennas, I guess that's going to be the first thing that we pull, because that'll probably be the easiest thing to tie back in. So let's get the old Gerber dam out, so we can grab that nut underneath there. And hopefully okay. So let's see if we get that. I heard it fall. I heard something fall. There it is. It's going to hide from me, of course. So let's get this nut put back under here. Okay, so we got the GPS antenna off. And now, let's see. As far as the motor controllers, looks like they're 1, 2, 3, 4. So they're pretty straightforward. So I'm going to go ahead and unplug them. And I've taken a picture of what I think is the receiver. So I'm going to go ahead and unplug it. Maybe I won't unplug it. So that is very janky. I don't like that. They've got, wow. So, and I've done stuff like this, so I'm not laughing at whoever did it. But they did good. They got heat shrink, but it's not the right size heat shrink on these two wires. Then they've got, I don't know what you call it, that clear present tape that you wrap presents with. I don't know what it's called, but that's what they call it there. And it's put on a JR connector. Just going to set it off to the side, but I'm definitely going to redo this connection. Feels like it's probably soldered in there, but I'm going to cut these loose just to make sure there's not some kind of random resistor or something up in there. It just looks like a pretty bad solder blob. Worst case scenario, I may pull these out and just remove these, redo the solder, and then put the right kind of heat shrink tubing on there. And then probably what I would usually do in a case like this, where I've got heat shrink tubing that's not exactly the right size, because this is small, tiny small wire, and so potentially you'd be hard to find some that would fit right. And so I will put some in here on this right here, and I have a larger piece that would fit over all of those. And so then I would shrink these down as best I could get them, just so that they would keep from making contact between them, slip the other one over top, and then shrink it down on them. And that would hold the whole mess together. And so I've done that several times to compensate for not having the proper size heat shrink tubing. But I do have some small butt splices that I may be good for this right here. I don't know, but we'll see what we're going to do. We're definitely redoing that connection. And so we're going to get in here and pull the motor connections. Okay, so that's got all of the motor connections off. So now what we've got here is telemetry. We have telemetry wiring, which I think we've got just jumpers. And this right here can be dressed up a lot. And I'll definitely do some dress up on this. But this is tying into the... I don't know if this right here is actually tying into part of the 4G card or using the pins going down into the Arduino. I'm sorry, not Arduino, the Raspberry Pi. So let me get a picture of this wiring to demonstrate, because I don't want to pull it away from this, but I'm going to take it off the controller because that's pretty straightforward for the connections. I'm just documenting that this wiring is going from the Arduino to the PixHawk telemetry port. And I can tell that it's telemetry port number 2 that it's going into. And so what I'll do, once I get this off, then I'll document all these connections onto this next board. I definitely want to leave all of this 4G stuff in there. And then we'll kind of move forward on it. And just because I'm going to get another picture of showing these two, the buzzer and switch. And so now we can pull the switch off and the buzzer loose. So we've almost got the PixHawk free. And this is just the power connection coming off of the, I don't know, power whip, par whatever it is. I don't know. We're going to go ahead and pull it loose, because that is a straightforward connection. And so here's our power supply. And I need to kind of check on this. It's a Cyrus power module, 6 to 28 volts. So this will go up to a 6S. So we got that. So if this will supply a 6S, then I got to do some research on this PixHawk to see what kind of voltages it supports. So I can kind of figure out what's my max battery size that I'm going to go with on this. And I don't know what the point of the buzzers are on a drone, but they're there a lot. And I don't know if this, see, this is a USB connection from the PixHawk to the Raspberry Pi. And it's in the top USB port on the Raspberry Pi, so that may be needed. So I'm just documenting that that is the case where it's plugged in. And let's undo that. And now we can pull this off. And I'm just going to disconnect. Maybe I'm not. So we're just going to do that off to the side. That's kind of stuck on there pretty solidly. We'll figure that out later. And let me take a quick break. I keep getting a phone call and I don't know who it is. So let's get a picture of this. So we'll see that there's two of these wires, and I don't think it really matters which of these black wires go where, but you've got LTE, GPS, and then LTE cellular on the white. So I just want to make it kind of obvious which ones of these are which. So we'll pop that loose. Maybe we won't pop it loose. We'll try to rip it apart maybe, because they don't pop at all. There we go. Okay, so I've got the antennas for the cell phone disconnected. So I don't even know what these wires are yet. But that is part of this conglomeration, which is, don't even know where that goes. So this is going around to here. And I think probably what's going on here is these are probably in parallel maybe, or series. See, all the reds are going together and then coming into here. So yes, each one of these sensors here are each color, you know, all the reds are together, all the greens are together, all the blues together, and all the blacks are together. And then they're coming into the controller here, and they, if I can sort all of this, because this is just a conglomerated goomagalli of twisted wires. So it looks like we got black, red, so here's our power wires, and then green. No, that's going to something else maybe. No, it's not. So this is a pretty twisted mess. See, the green is going straight into here. It looks like they use liquid tape. Not efficiently, but they use liquid tape to go on here. They should have made a wire loom for all of these. But that's, we're not arguing about that. So black goes straight into that one. Looks like we got a resistor coming off of blue on this one, tying into the black here, which is then going to red here. I'm going to be honest, I mean, this right here, I guess, really just needs to come off altogether, because I'm going to have to kind of get nitty gritty with that thing to figure out what's what, because it is not kosher. I'm telling you, tain't kosher. So let's go ahead and clip this towel wrap. But we're not going to do it with the dime, because the dime ain't clipping. You know what this is? And then we got the wires. Let me see if I can figure out how to get, see, not good. We're going to see if we can do this a little better when we put this back together for sure. Maybe we can't, but we're going to try. Well, let's get our tools out. It was in there. I had to pull everything out to find it. No, wouldn't have it any other way. I will not stand for anything to be simple. It is just unacceptable. What is trying to twist under there? I believe this sounded like a good idea when they did it. Hopefully I don't tear it up. It may have been working before I took it apart, but I'm not going to power something up like this right here. Because if it looked a little more neater, professional, tidier, not so many exposed wire joints and stuff like that, I probably would have chanced powering it up. But with so many potential shorts, there's no way I would power that up, because I really and truly think it would short out. Get that off there. And so it appears the only oh wow, look at that. Come on, that's nice. Not really, but we're going to call it nice. I wish they'd done it here. They did. And they taped it. Okie dokie, my little pokey. So this is the whole setup, and it's now freed from the frame. So that's nice. This I have to figure out. Because this is a powerful mess. And I've got to get some pretty good pictures of this so I can understand the circuit and how they're using it. And it's probably just standard, to be honest with you. I don't think it's anything out of the ordinary. But black, blue, green, red. So they did keep it uniform. So that was nice. Okay. And so really, this is going to be the same thing, but let me see if I can get it, because it's Velcroed, sticky tape Velcroed. There we go. So now we have the flight controller disconnected, and that will just drive me nuts. So that can't stay that way. That has to be straight, or it's not acceptable. But I don't know. I'll probably reprint all of this stuff and probably a different setup. Probably. Those seem to be metal spacers. That's nice. So anyway, we got that. And so we've got most of this worked out. So this right here was the telemetry. So let's document the telemetry pins that are used on this board. And this was in telemetry 2. Right there. Anyway, right there. So let's see. Let me do this. I'm going to plug it back into the telemetry 2. And I'm doing this so that, because if I just raise this up and take a picture, then I know the orientation of the board and how the pins are plugged in, and I can completely pull this off the board at that point. But I may forget exactly what that was, or kind of lose track that it's in the telemetry 2 position. And so I'm going to just take and hold these wires and hold this in a loop next to it so that I'll have a better understanding and documenting that these 4 wires are telemetry 2. Get the whole wire loop in there, and then we're going to get a better picture. And let's see how that looks. So I look in here, we got red, black, blue, and white. Red, black, blue, and white. And we got some other red one that's working on the I wish I could remember what these things are called, but it's working on these. So, all right, so that's good. So I can go ahead and pull these loose. So now I have the telemetry wiring out of the board. Now, let's see. How these are looped. Looks like we have so the red off of these 2 are tied together using unshrunk heat shrink. And then it comes together here to tie this one in on the same deal. So to be honest, I don't know. I prefer to make straight runs from my sensor to a junction, and then from that junction have one connection coming in here, and all of my splices being at that junction point. Or maybe that's electrical coming out in my background, but that's what I prefer to do. So that's how I'll clean this up. And that appears just to be a clunky solder joint that's mostly exposed with some liquid tape on it. And these are kind of the same thing, but we're going to, being as all of these are looped together, I'm going to say that's probably, and I think what do these take? 3.3 volts maybe? I'll just have to research that, but, and I don't know. These may be 3.3 volts, but these are all tied together going into VCC. And so you got black is the ground. So on ground, you again have the grounds tied together. It's going through, and it just broke loose, but these grounds are all tied together on this side of some kind of resistor network. And then it all comes into here, and I assume that's probably ground on the board, and this one's tied in as well through another resistor. Then you got trigger and echo. So the blue is echo, green is the trigger. And so there should be 3 green. Yeah, okay, so 3 green. So we got 3 triggers. So that's the signal coming back. And then blue, we've got 3 blues. So I would have to know, let's see. See, these blues, see, and they're changing wire color. That I hate that. Looks like they're coming off of the echo. And also branching off to ground. And never change color. I mean, I just don't know. We'll do something else. We'll follow suit with colors, but I've got to figure out what this is and what it's doing, because we've got black and then blue is also together and coming through the middle of the resistor network to there. I don't know. I think I may just trash all of this proximity stuff and either build that back in from scratch or something. I don't know, because this is just, it's just too wonky. Let's see, this one was tied back in over here at the end. So this is straight up ground going from each of the signals in here. So it looks like they're using 2 separate grounds. They're coming out here for ground and just looping into the resistor network, which the blue is coming across both resistors to ground, and then you've got, I guess this would be the other side of the signal for the trigger, which is green. And so the greens are tied into each individual port on, probably tying back down to the Raspberry Pi. And the blue is over here. So they're using 2 separate grounds. The 3 separate triggers on green, and then they're coming off with 2 blues. Looks to me, and y'all correct me, because I mean, this is not my strong point at all. But from what I can tell, or what I'm thinking, and you circuit board gurus, look, I need your help. What I think is going on here, they've got all of these tied in parallel with one another, and if you see if any one of them comes near something, then it's getting a signal from what individual it is on green. Is where it gets its signal, telling it whether it is bottom, top, or straight ahead. But this resistor set up here and down here, as far as I'm concerned, has got to be that's just going to have to be a circuit board or a breadboard. A breadboard would be fine. And so let me just get some pictures of this. So I'm showing green as being right there on that one. And I'm showing these two greens being in here. So I'm going to pull that loose, this signal, that loose, and that loose. And then we're going to show all the reds, which are the power. And I kind of remember the pinout on a Arduino, and I think this would be 3.3 volts. But on the Raspberry Pis, I don't have a lot of experience with them on programming them. So I don't think this, this is probably 3.3 volts. I don't know. But I don't know what the load is, because usually the load is, I would think these would be a higher load for what you would need for an Arduino. But these, I don't know. So this sensor is using two here side by side, and these sensors are all tied together. This is separate, and these are all tied together, which doesn't make sense, but maybe it does. I don't know. So let's get a picture. So in a case like this right here, what you do is take a million pictures. So this is all the proximity stuff. And if this goes back in there, there's going to be a breadboard and probably replaced by a hard circuit board, a handmade, a custom-made hard circuit board. And so that brings us down to the last part. This plate. Let's see, how big is the card? 64 gigabyte, or is it gigabyte? Yes, 64 gigabyte in the Raspberry Pi. And let's pop this off, because I would say that it would be worth getting a Pi camera to loop up through here to be the camera part of this particular setup. Okay, there we go. So, and this board right here is designed so you could, looks like, power this polarity, external 5-volt input. So you could run a 5-volt input right in here. But we'll have to look into all that and to see how this all, we got to go back in there. And so this chip right here, I should be able to re-register to myself. Shouldn't be a problem. And the Pi is a Raspberry 3. It's a 3. So you don't need a big fancy Raspberry Pi for these things, but I don't guess it seriously hurts to have that, in all honesty. But the Raspberry Pi, I would not put on my flight stack. And reason being is, and I think they usually put the flight controller on these. I don't mean to call that a gimbal. I don't know what you want to call it. It looks like it's 3D printed, and it looks like it's probably going to be 3D printed. That is not good. Had their settings wrong on their printer. Bad wrong. But you would have this, you have your flight controller on this, because a lot of times you have a gyro and a GPS and all kind of stuff built into here, and this thing sitting here is just steadily just going all over the place. It may mess up your gyro or something like that. I could see that happening. But this mounted straight to this, I'm going to call it a jello plate. I don't know what it is. But I think it would potentially cancel out some of that vibration of the drone itself with the propellers turning. And so I would see that connected only. With all this on there, that just seems like that's going to give you even an exaggerated movement. And I know these Pis, it doesn't have to be rock solid to run. I mean, these things right here can be moving around or whatever and still run. It's all solid state in here. And so you don't got a hard drive that's going to mess up. And so I think we'd be fine in mounting this section of the build in the center deck or in the middle deck. And then probably just running this on top and with the flight controller, and then mounting the battery underneath. So anyway, so we got it tore down this far, and the only thing really left in the drone itself is the antennas, which I'll probably, just to save them from bouncing around, I don't know if there's, looks like they may be glued down or something, which I don't like, but who knows, I can't do nothing about it. So I probably won't pull them off, though I'd like to, because these wires just flapping around, I'm afraid they'll come unsoldered. But the motors, they're in here with the ESCs, and of course the motors themselves. And so there's not really anything left on this portion of it. But I am going to, and you can see it on my other drone build, that as things are being, it's being built. So you don't need to, but I'm going to pull this top plate off, pull these arms out, have them all set and separate, and I'm going to resolder these joints down underneath here, because I really don't like the solder I'm seeing on those. So I'm going to redo that to make sure those connections are good. And there's no reason to video that. I think we'll be just fine. Calling it a thing here on the disassembly of that drone. And we will work towards building it back up again. So what I may do, and this is a HDMI connection. I can run power in here. I think the Raspberry Pis are 7, 8, 9 volts or something like that. And I have some power supplies that I can hook one up, and I can hook this into my monitor up there or over there, and get a good idea of if this functions, if it's working, booting, and then, kind of check this stuff right here out to make sure that it is as well. And then we'll go from there. I hope you appreciate it. I hope you enjoyed it. I hope you learned something, and I hope you can teach me something on some of this stuff that I really know nothing about, but I'm learning as I go. So I enjoy spending time with you. I hope to spend more time with you, and I appreciate you being here, and I will see you next time. Your time is very important to me, and I thank you for spending it here with me. Thanks, and God bless.